The room is yours.
Good. Hello, everyone. Thank you for attending this meeting. So my name is Hervé. I've been using OpenRefine since, I think, 2010 or 2011 or something like that. I'm really fond of this software because it really opened my mind to many disciplines like data science and many other things, machine learning, now LLMs, etc. It's a tool that I've been using a lot to clean the data, and I've taught it several times for my former colleagues, but also at Data Harvest for beginners, but also for advanced users, a little bit more advanced users. So I've been playing around this tool. And last year, thanks to Sunil, I'm very happy to see him online today. I saw this extension and I immediately saw the benefit of this extension for data journalism, which is more or less my background. I left one link in the chat. We published a report at Check First. It's not promotional whatsoever, but it's a report on this information. And I use OpenRefine to clean at a certain moment some of the data. And you may be interested in it. Check First is a Finnish company that I work with, and we work basically on this information. This presentation is going to be as quick as possible because I want to show you and demonstrate the use that I have on OpenRefine with this LLM extension, and basically with a self-hosted LLM, which is really important when you do data journalism because basically for privacy reason. So why OpenRefine for data journalism? Reproducibility is the whole point of OpenRefine. When you clean data set, you want to make it possibly reproducible. And OpenRefine is perfect for that because every action on a column is recorded as an exportable JSON operation story. So you can repeat everything, send your data set to your friends. They can correct yourself. So it's brilliant. And also a third party can audit your workflow with it, which is something very interesting when you do journalism. So of course, OpenRefine has always been a tool that is really used a lot by data journalism, even though now there are a lot of Python libraries that are quite efficient. But as soon as you talk about clustering, for example, OpenRefine remains the only tool to do that conveniently, easily reproducible, and above all, that can be used by total beginners. So it's very graphic. Of course, you can use Grell, the language of OpenRefine, but some of and the clustering tools also, but sometimes you get blocked by several things. For example, if you want to discuss facts and opinion, for example, in the dataset that I'm going to use, the expression a 6-hour delay is something very factual. The flight was delayed is not very factual. So you start to see here the concept of fuzzy contextual boundaries, etc., which is not exactly a pattern that you can extract from a data set. Also, you can work on sentiments, you can work on concept, etc. And Grell is not very useful to do that or extract data from that. And especially in the data set that I'm going to show, you can extract data in a more efficient way than traditionally, let's say it like this. And this is where LLM are very good at. What I'm going to demonstrate is the possibility to use OpenRefine plus LLM on a self-hosted machine. Typically, I use a simple MacBook with 16 gigabytes of RAM that allows me to use a 3 billion parameters open source model called Ministral. You can use whatever model you have depending on the class on the machine. But as soon as it's compatible with Ollama, I don't know how to pronounce it in English, you can use it. And this is very important because no data leaves your machine. You can work perfectly disconnected. You can work in a train, in a plane. Personally, I sleep in planes, but if you want to extract data and clean data set in a flight, it's possible. It's also very important when you do data journalism to protect your source and to not send confidential data online. So it's very important. There is no token cost, and as you probably know on LLM, the price of token is going to increase a lot. So as soon as you're able to work locally in your machine, that's perfect. It's free, so you can do a better thing on your machine. So the stack that I use is mainly based on OpenRefine, of course, the LLM extension. I use Ollama on my machine, so you see this little icon. I don't know if you see it here at the bottom. And the local model, as I mentioned, I used Ministral 3B, 3 billion parameters. It's enough on my machine. I can work quite well. But of course, there are other models that you can use, 7 billion if your machine is powerful enough. But you can also use SLM that are fine-tuned for several tasks. This is something that we try to develop at Checkverse, like very small model, very efficient on unique tasks. So you can use this kind of model. So this is why I presented that at Data Harvest this year in the data journalism conference. And why is it important? We talk about reproducibility, and of course, there is a sort of dilemma here because LLM are non-deterministic by default. So the same prompt can give different answer across runs. So for every example that I'm going to run and to show you, I give the model version, of course, I fix the seed, and I give a low temperature for the LLM. It allows me to have the maximum reproducibility thing, and I assure myself that the LLM is not going to hallucinate or to give too many details to its response. So that's also very important to take note. LLM are non-deterministic and they can hallucinate. So this is probably the let's say the black. How can I say that in English? But the caveat of using LLM. But still, by fine-tuning the low temperature in the seed, you can really reproduce your actions. So I already started about the limits. Use it as a filter, not as a measurement. There is an error rate. So, of course, you have to take that in mind and keep a human in the loop. That's very important. Some understatements are missed, like this, for example, this seat was adequate. You don't see if it's positive or it's slightly negative. You don't understand that. So sometimes you will have to correct your dataset, of course. There are also, of course, like in every LLM, some bias. So be careful. Test on a small sample first. Use bigger model. As soon as you can have a 7 billion, you can mitigate the risk of error. And my basic advice would be to always keep the human in the loop. So there are caveats, of course, but even if there are caveats, the result can be quite cool. Okay, so I'm going to demonstrate this. In order to do that, there is a repository here on GitHub that you can find. I'm going to put the link in the chat here. And in this repository, you've got everything. You've got, first of all, the dataset that I'm going to use. It's an extract from Kaggle. So for this demo purpose, I use a 100 lines sample, but you can do, of course, this on many, many more lines in the dataset. So I extract this dataset from Kaggle. And this dataset is an airline review sample. So it's basically well-structured and not well-structured text. There are plenty of full text paragraphs and opinions on companies. So this is why it's very interesting to work with LLM. And for every transformation that I made or every use case, I classified them by difficulty and interest. So 0, is the basic one. Don't do that with an LLM. There is a perfect rel function that does it. But then you can extract several entities using this dataset. Okay. So let's start, for example, with the dataset. So I opened here a window of the well-known OpenRefine on the project. So now this is basically the data set. So you have the company name, the overall rating, the review title, the review date, if it's verified or not, the review itself, the type of the plane, etc., etc. So it's a classical data set. I'm going to create the project here. And this is it. So our interest would be in working on the reviews. As you see here, I'm trying to zoom a little bit. Yes. So as you see here, it's a full text area. So people basically work their opinion on the company. Here you've got sometimes the aircraft, sometimes it's not written. So basically here, what you see is the first issue. If you want to classify the aircraft, of course, you've got the Boeing 737, but here it's 737, the 800 version. Sometimes it's not written. Sometimes it's A320, A321, which is basically the same plane, etc. So as you see, there are plenty of things that you could do to enhance this dataset possibly. Another interesting thing is the route that was taken by the flight. For example, here, as you see, sometimes the route is direct, like Manchester to Rhodes, but sometimes you see like the trigram or the code for the airport, for example. So imagine yourself, you want to make, as a data journalist, a graphic or a sort of map of relation between airports and other airports. This is the first difficulty because, of course, Hong Kong is not written as Hong Kong and PVG not written as whatever it is. So that's one of the difficulties. And this is typically the kind of data that is interesting to deal with an LLM. So, for example, the first thing that you could do is to extract some interesting information from the review itself. So let's go back to the transformation. From the review, we could probably extract something like the primary complaint. It means you want to extract from the characters that are written in this thing if the problem was the delay, the cancellation of flight, or the lost baggage, rude staff, impolite people, seat comfort, food quality, etc., etc. So this is typically the kind of thing which is quite difficult to extract using GREL or clustering inside this information. So what we are going to do, first of all, we install the famous LLM extension. And here you've got the menu that appears. And here you can set up your LLM. So here I can do edit in order to see. So here we have the Ollama Ministral Extraction. That's the name of my version of LLM. Here you have the server. You see it's a local one. It's on my machine. It's given by Ollama. This is the exact model that I use, Ministral 3.3b. The API keys is Ollama, it's whatever. And by default, what I use is the temperature of the LLM. So I'm going to say that it's quite complicated to define, but the more you get close to zero, and the more the answer will be precise, and the LLM will not hallucinate or give too many information. For here, the top P, I always maintain it at 0.9, and probably Sunil is going to explain that much better than I do. And here, this is by default, I use a maximum token output. So basically, it's interesting if you use an answer as 2 or 3 words, you put like between 8 and 12 here. I will explain that later. So this is basically the way that you program the thing. And now we are going to use that. So let's say that we want to extract the data. Here on every markdown file, I have extracted a typical prompt that I use for it. So here I just copy the prompt that I've made. So the prompt is the following. So you're a complaint classifier for airline review. Your review, you don't invent new label. this is what I want to see, delay, cancellation, blah, blah, blah. And here are some rules that I give, use none if you don't see anything relevant, other if you see something that there is a complaint, but it's not in the predefined vocabulary, etc., etc. And I give some example like this, and I set the format to text. So I just copy this scenario, and I do this. I go to review, extract using AI. I'm going to add a new column that I name, let's say, like complaint, for example. So this is the name of the new column. As an LLM provider, I use my local one, which is the one that I program. The response format, I want a simple text. I don't want a JSON, but I could. And I don't want a JSON object, I want a text. This is where I'm going to provide my prompt. So I copy-paste my prompt. And here, there is the preview. So I can see if based on the first line, there is something that goes for it. So I generate the preview. The first time that you initiate the LLM model, it's going to go in the memory. So it takes a little bit of time. And after that, the process goes much faster because the model is already in the RAM. So this is the first round of testing. And as you see from this original value, the LLM detected that it was something related to seat comfort. Okay, so I'm going to do exactly the same for the rest of my columns. So I'm going to say, okay. And it's going to take approximately 50 seconds to deal with the 100 row. Once again, the first time that you launch the LLM, and because my computer is not very powerful, once again, it's a MacBook Air with 16 megabyte of memory, it's going to deal with it and create a new task from a new column based on what I see. So this is the first example that I want to illustrate. As you probably see, my machine has lowered a little bit. It's because I'm at the maximum of the capacity of the LLM on my local machine, but it works well. So basically what I define here are several languages. We've got the primary complaint. We could have the sentiment also, if the sentiment is positive, negative, rather, etc. We could also do something which is quite interesting. It's the discrimination signal. So this signal, this is very interesting because this is something that you cannot do just by using the traditional GREL function, is to extract this information based on discrimination of genre, of races, for example, of races, sorry. And of course, this is quite subjective, or at least not very obvious to extract from a traditional text. But this is typically the kind of thing that you can do using an LLM, okay? You can also find, so there are many things like this. You can extract data like if the compensation was given to the person or not, if they claim for a compensation, but we are not given the compensation, if the company intentionally give them a compensation without any claim, etc. This is the kind of thing that you can also extract just from pure text that is visible on this document. And of course, you can also try to extract some named entities. So I know perfectly that there are plenty of very good machine learning tools that are available to extract named entities. But it can be also interesting to compare with the result of what an LLM can do in this situation just by using this kind of tool. So once again, this is the only demo that I will make. We will wait for the completion of the airline thing. But this is the kind of usage that I have of this LLM plugin. So once again, you will find you will find the slides and you will find all the possible scenario that I created around this for this training for data journalists. And it's available on the GitHub repo. And yes, this is it. So I'm going to go back to the presentation, and before we get the result, to explain you a few things and a few takeaways from that. So yes, I don't know. The last thing that I wanted to show is that for every scenario, I've written some values, some sort of ideal values that are available for the temperature. So here, for example, what we expect is a signal, possible, ambiguous, etc. So I put the max token to 12. I maintain always the seed as 42, but the temperature, as you see, is very low, 0.1. It's very close to 0 to maintain it. And I hope, and I will give the floor later to Sunil in order to extract, to explain what it means for everyone. So some key takeaway from that. OpenRefine gives you reproducible, auditable, self-documented data cleansing, and that's super important. And this LLM thing unlock transformation Grail and clustering because they cannot do that. It's impossible for Grail to extract this kind of information this way, to deal with full text and extract some data that are very difficult to structure by themselves. Of course, it's better to self-host your model. And once again, this is why I use, and it's a bit slow, I'm sorry about that. I've been dealing with several models on this machine, and I think that the memory is, believe me, for the presentation with journalists, it was way faster. But self-hosting your LLM is really important because it maintains your data confidential, your cost to zero, of course, which is important. So make it as reproducible as possible, and above all, maintain a human in the loop, and that's very important for this presentation. Always verify what the LLM has done, filter if there is an error. On most of these scenarios that I made, there is a sort of, how do you say that, backfall? It's a fallback. If there is nothing, then it will show something like NA, and it will help you to assess if the data is correct or not. So let's go back to the data set. And as you see, for example, here we have a new column with the complaint, the basic complaint that we have. And now we can facet this by text and say, most of the companies on this data set, it was a problem of lost baggage, route staff, cancellation, etc. So once again, this is something that was not very obvious from the review text. And now you have a sort of column that helps you to cluster this information in this way. So I hope this was clear enough. I don't want to spend too much time and give the floor to the other presenter. If you have any question, I will be here to answer your question if I have the answer. Thank you so much.
Thank you, Hervé. And we invite everyone to review the repository Hervé shared. There is like the different tutorials are very well explained on like how to use what's the prompt, how to read the prompt. So I think it's a treasure trove if you want to understand like really the limitation also of the LLM using those different small tutorials.
The prompts are not perfect. You can probably enhance them, and don't hesitate to contribute to this repo, to modify them, add some new sample if you want. Feel free. I mean, that's really important.
So idea is now to move directly with Partha presentation, and then have all the question after his presentation, so we can have two different use cases and have enough time for his presentation.
Thank you. So first of all, a sincere and heartfelt thanks to Sunil for developing this beautiful, AI plugin, and Marty to take all the pains to gather us here. So I will keep my video feed on off during the presentation, and again I will come on. So I don't have any slide to present before you, but the way I planned this one is basically a case study basis. Okay. So can you see this? Is it visible?
Yes, it is.
Yeah. So I prepared, as Martin told me that some of you will be the very newcomer to this AI plugin. So I prepared this in a manual kind of format. Again, of course, by taking Ollama as a test case. Because you see that you can bypass Ollama or any kind of commercial aggregator like OpenRouter or Fireworks. If you go directly to the individual LLM, each of these LLM nowadays provide API. But in that way, it is very difficult to manage all individual LLMs, their different kind of specification like max token, etc. So it's always better to have an aggregator in between. So in case of local usage, generally people use Ollama because Ollama is far ahead in compare with other, comparable local hosting services or local platform like GPT for all and so on. The beauty of Ollama is that it's platform independent. Any operating system you can use. For example, I am using here Ubuntu. You can use in Windows, and it provides CLI as well as the web user interface and API based access. So that's why we people use Ollama. Now, in case of Ollama, if you go to this particular, Ollama site, it's a single command to install Ollama. Just you give this particular command in case of Ubuntu, and there is equivalent command for Windows also. It will be installed very smoothly. And the moment it is installed, you can have this particular interface in your local host, and it will say Ollama is running. It will not do much better than that. It will simply say that Ollama is running. Then the next task to obtain the model, available LLMs or models inside Ollama. It's not that every model is available inside Ollama framework. You need to check what particular models are available. You can go to this particular site, ollama.com library. All the model details will be available there. And a few useful comments I have given that after installing Ollama, after installing a few models, what are the models available in your local machine and so on. But when you are talking about models, models can be of two types. Say, for example, as Hervé rightly said, that if you think you are very conservative about data, data should not go outside of your computing system. Then it is always better to have a local model like a Ministral or a Llama 3.2 or 3.3. But in that case, you cannot go beyond 2 billion or 3 billion parameter, because you roughly say 1 billion parameter will take 1 GB in your hard disks. So if you are going to install a 16 billion parameter model, it will roughly take around 20 GB of your hard disks. So not always, you have to, compromise with the parameters of the model if you want to install it locally. For example, Llama 3.2 4 billion model takes almost around 5 GB of data in your hard disk. So another option for Ollama is that you can have a cloud-based model. So you can go to this Ollama site, particularly ollama.com settings API key, and this manual I'll be sharing with all of you, no issue. So first you enter inside your Ollama by using your Gmail ID or something like that. Then you can go there and have an API key. And then you come back to your machine and export that API key by using this particular command. And the moment you do that, you can see here, I can say Ollama list. So all the models what I am presently using here, because as local models are slow, and in the library world, our data is not that kind of, that kind of protection we simply do not need. Most of the data are already available in the public domain, bibliographic data. So you can use these different cloud models available. For example, one of my favorite is GPT-OS's 120 billion parameter. This particular model is completely open source. It's a community model, possibly based on the commercial model GPT from OpenAI, and it's working nicely. And in case of Ollama cloud environment, they generally provide generous amount of free usage as per token limit, as per per session usage or per day usage, quite sufficient for library jobs. So in this way, we are utilizing Ollama cloud through after signing in, and after you select your model, export your key exportation is over. You need to sign in through this particular command, Ollama sign in, and then you select a model, and this give this particular command, Ollama pool model name. It will create a model file locally, but it will not install the entire model locally. It will create a channel between your local copy of Ollama and the Ollama server, and that is the cloud server. So in this way, we configured n number of cloud models, and the beauty is that it's very fast. And as I said, depending on your usage, like in the free tier, you can run one model at a time and reset every 5 hours and 7 days. So quite good, quite generous for testing and building something. So on the top of this, if I go to my this interface, say for example here, let me increase it first. So here, this particular plugin, you can see we have added lot many models, from lot many providers. There are commercial provider like God or Open Router or Fireworks, as well as Ollama. One of the let me bring this particular point for discussion. One of the limitation of this particular plugin is that, say for example, in Ollama, I am using 6 models, 6 different models. So six times I have to create instances. So it is model specific approach. In that place, if we have a provider specific approach, suppose I am adding Ollama single time, and then models I can select against a particular operation, and the API key and everything will be same. So it saves some of our time. Otherwise, we need to create, for example, you see, if I am using Ollama GLM, then one particular instance, Ollama GPTSS, another one. So presently, we are utilizing this particular model heavily. And this is basically the configuration what I use. As Hervé said, lower temperature means you are actually telling the model to give answer factual and deterministic. But I use top P 0.1 based on my experience with working through this particular plugin. Because when I see that low temperature and this top P when I set to 0.9, so there were some factual errors. So the moment I reduce that particular top P value to 0.1 and both temperature is 0.1, that factual error actually disappeared in the long run. Say for example, I'm throwing almost 5K of data to do something. So in the long run, it actually given me better result, this combination. And max token, you need to be very clear about that. It's always go to the model data card or model card and to note down the max token they support. The moment you give here, say for example, on the basis of some base, you are giving some value which is exceeding the max token limit of the model. And the plugin and the operation will fail silently. It will not report you anything, but it will fail silently. So be very clear about this particular max token they support and what particular average token you need. So that you need to select. And another one, when you are using cloud, the time distance or time gap between two consecutive requests. So it's in milliseconds. So 15,000 millisecond means I am sending 4 requests per second. But for some model, it's always better to reduce to 30,000 millisecond. So you are sending 2 requests per second or even 1 request per second. So the moment your this thing is over, you can save it. Now after saving, you first test that whether your model is working or not. So the moment you click test service, so it is a hard-coded thing. What is the capital of France? So it will always tell you Paris, and that is the testing phase is over. Now, after this brief introduction of how to configure this AI plugin, let me show you some of the interesting case studies that we are presently doing for the university. And our university and this particular AI plugin sometimes acted as a lifesaver for us. Why I am saying so? Because uh, 2 days back, one request came from our register office that whatever publications available or done by the university faculty member or researcher in the first half of 2026, that is up to 30th June, we need a male-female ratio, and central government requires that data. So we downloaded all of our records from OpenLX, this publication records up to June 30 by University of Ollama. So you can see here, this here authors are given by their forename, surname, and separated by a pipe sign. So actually there are 691 records so far. So I have just selected 5 to save some time here. And here comes the prompt. It's always one of the most difficult thing to craft is the prompt, and possibly English is the latest hot programming language in the world. What I particularly think. So here what we created a particular prompt, keeping in view the output we need, and then if I target this particular say, now if I target this particular 5 authorship pattern and use this particular plugin extract using AI, I'm selecting Ollama Cloud. The output is text format. Then I am giving this particular prompt. And as Hervé demonstrated, that you need to first check the review, and you need to tinker if review, general preview is not working exactly the way you want. So now you see it takes the first name of the author, and on the basis of the first name of the author, it actually give the gender of the name on the basis of the name, and at the end it is actually saying that you for this publication how many female authors and how many male authors. Now the moment you are satisfied with this, you can simply click OK, trigger your action, and it will do this for this 5 record or the entire 691 records. So that is one of the thing we are doing now and then, almost every month, to send the report to the ministry. Now another, as sentiment analysis already demonstrated by Hervé, now I am going to subject indexing. So another beauty of this particular plugin is that without knowing programming, we can use large language model programmatically. That is one of the great benefit of this particular plugin. All credit goes to Sunil. He did it beautifully. And here you see, we have collected a few central government schemes, and the demand was that all the schemes we need to classify or index by sustainable development goals. So you all know there are 17 sustainable development goals. So which central government or state government schemes are exactly matching or satisfying how many goals there may be. At the best or at the most, they decided that 3 goals can be associated at the most against a particular project. So here you see, if you want a direct textual format, uh, that always can be done. It's a very simple kind of system prompt we are using, that you read the particular corpus and give the top SDG, the single most dominant SDG, in the form of this particular metadata structure. So if you need that kind of simple thing, then this is the instruction. Again, I am selecting text and then GPT. So it will now read the corpus and it will give me the first single most dominant goal associated with this particular project description. But my experience, again, when we are utilizing this for 5K records, so we are having basically 6,000 plus, almost 6,000 projects, central government and state government projects in the data set, and we need to align the corpus with the corresponding sustainable development goal. Okay. So if we want, in the long run, what we have seen, that sometimes it silently fails and it returns no particular goal, or sometimes goal is associated with additional comments and everything. So this is very important to tell every time for this kind of task, that do not output markdown pages or additional comments and everything. So it's better to go for JSON object or JSON schema dataset when you are running this kind of categorization, classification, or indexing tasks for a huge corpus of 6,000, 10,000, and more than that. So in that particular case, what we use a particular format called JSON format, JSON schema based this one. So for example, I don't need a simple textual output. Rather, I want from the LLM what is the label of the SDG, what is the notation, that is goal number, and what is the score that particular LLM thinks that this should go high, this should go middle, and so on. So it should be arranged by score of relevancy in descending order. So in that particular case, we use this kind of structured, schema, structured instruction. So here I am selecting that structure instruction now, and I'm selecting you go by JSON as schema. So the moment you select JSON as per the JSON schema, so you need to give the JSON schema. So this is my target output. So for this particular target output, we need to create a JSON schema like this. So I'm selecting this, and don't worry. So if you give your output, say for example, you imagine an output in that particular way. So you give that output, any large language model can convert that output in a schema like this. So you do not have to do anything. I'm not a programmer at all. So now I'm giving the schema here, and now I want to generate review. So now it will go through fast by my description, the instruction. Then it will, decide that what particular JSON schema has been provided. On the top of that, it will give me data structure exactly the way I need it. So sometimes you all know, Hervé already told you the power of Grail in OpenRefine. So now I can extract the score given by LLM, the particular goal, and it's actually arranged everything in descending order. Higher score categorization will go high, will go at the top. So this is one of the, in the long run, when you are running a big corpus, a big data set, it's always better to go for this JSON kind of, JSON schema kind of request, so that your data is manageable. You can extract, any element you want later on. Now, the third and the final case study, what I'm going to show you, say, another kind of problem that we generally face in library world, particularly this is very specific to non-English speaking countries, libraries in the non-English speaking countries. You all know that when you want to enter multi-script record, suppose my books are available in Indian languages, Bengali, Hindi, Oriya or something. We have 22 languages constitutionally recognized. So if I want to add those, multilingual books or Indian language books, so there is a rule in MARC that if you want to give your data in native script or your original script, then you need to include the corresponding, transliteration in 880 tag. So sometimes it become very difficult, very, tedious kind of job for a cataloger. So we are utilizing this particular kind of, facility of AI plugin integrated with LLM to create a base record. And as Hervé said that you need to have a human in the loop always. So I'm quite agreed with that particular thing and that particular advice. But at the same time, if my base work is done, then it is quite easier for a human cataloger to check what went wrong and what went right. So for that particular purpose, you see here how powerful nowadays LLMs are, and because of this plugin, how easily we can do that. If I give the basic rule that I am entering 100 and 245 and so those kind of fields in native script, and I want a perfect mark record with with 880 tag, then you see how it can perform that one. So this is my third database. I have only 5 multilingual documents, Hindi and Bengali. Now you see, if I say extract using AI, and I'm again selecting GPT OSS through Ollama, and I want text, and this is my instruction. If you read this instruction, you see here that I have given that always put an equal sign before every tag, so that my the mark record produced by this LLM should be repurposed by using mark edit software. You all know that mark edit always need that particular equal sign before every tag. So you see here the result. First I am previewing it. It will take some time because mark record, if you are using cloud, then also it will take time. So now you see it perfectly on the basis of that, instruction, it's perfectly given 100 author as well as corresponding 880 in transliterated format by following the ALA transliteration rule. Now the moment I click OK, I forget to give a label, say test. So now it will start working for this particular 5 records, and at the end of the operation, I will be having a complete, mark record for this 5, rows, and then I can utilize this, templating options of OpenRefine that to export my system in perfectly marked format, and then we can add that or open that one in mark edit software or any that kind of software. So this is called templating. You can utilize this one. So it takes time because you are giving the data set, and then the entire mark format is coming with subfield and everything. So that's all from my end. I hope I completed within time.
That's great. Thank you, Partha. We have like scheduled like an hour and a half, so we still have like 25 minutes for the conversation. And that was a very insightful presentation. Really like how you explained the difference within the different models and the three different use cases. If you can maybe share, I don't know if you can share your document later on, Partha. I think
Yeah.
that will help anyone who want to reproduce. Now it's time for questions, comment, really having like an open conversation. Feel free to raise your hand or just to unmute. And if you have question or comment to Hervé, Sunil, or Partha. Or if you want to share some usage you have with the LLM extension. Yes, Joe. And then we have Rosanna. Okay, Rosanna, go ahead. I don't know if Joe raised his hand.
No, I didn't. Sorry. You're good.
Okay, go ahead, Rosanna. Nice seeing you here, by the way.
Yeah, hi everyone. I missed the intros part, but my name is Rosanna. I work at the TAB, German National Library for Science and Technology, and we use OpenRefine a lot. Thanks to all the presenters for the really interesting demos. I will definitely share them with my team later. And I have a question. It's to the presenters, but also to anyone else in the room. Has anyone experimented using the LLM extension also to do things like reconciliation or entity linking with, Wikidata, something like that? Because that's for us like the major use case to use LLMs. But we haven't done anything with the LLM extension yet.
Well, I answered in chat, but I haven't experimented that use case so far, so I don't have any answer on that. I'm sorry, Rosanna.
No problem. Thanks.
So hi, Rosanna. So quick question. So OpenRefine does have an tool to do reconciliations, right? Against any Wikidata source. So are you looking for something beyond that reconciliation?
No, I just was hoping that with the LLM we can get support for the reconciliation, because reconciling against Wikidata, if you don't have a lot of context, is actually quite hard. And what I mean by context, so if I have like a list of 1,000 people and I want to reconcile them to Wikidata, if I have something like an external identifier, then the reconciliation is really easy, right? But if I don't have any external identifiers, maybe I have some free text describing these people. I can't use that text directly as context to help the reconciliation. So I normally, what I get after, like I just say reconcile these 1,000 people, I get maybe like 100 perfect matches, and then I get like loads of matches that are quite bad, or I have like, 50 potential people that I have to manually review. And if I can use an LLM to help with this reconciliation, that would be like, for me, like a winner, at least for our use case here in the TAB library. But yeah.
That's interesting. So the first step would be to run the existing reconciliation tool. You get all the options, then run another review with the LLM extension to say wherever there are more than one match, kind of narrow it down to basically the best match.
Yeah, and I can also share. So we have, at the moment, we're working on a project, a European project here in the TAB called Ecolot, and in that one we are developing some LM-based tooling, but we sort of never thought that we can use OpenRefine. We thought we have to sort of do everything from scratch. And we have like a workflow engine at the moment, Prefect, and then we run yeah, like we've tried different reconciliations, like for example with Claude, like an agentic workflow with Claude works quite well. Because what we can tell Claude to do is like, okay, here's like a bunch of biographies for these people, like use the biographies as context and then try to match to Wikidata using the Wikidata reconciliation service, but also being able to like extract this like random biographies that, okay, this guy's a photographer, so don't give me the match for the footballer with the same name, right? Like this kind of operation. But what we don't have so far is obviously when we do this with a completely external engine and a completely external like model, we don't have any kind of UI that like all the kind of potential for human in the loop that OpenRefine offers. We don't have that, or we would have to invent it again, or we just like let people endlessly talk to the AI, but that's expensive, and like also what Hervé said, like, yeah, we don't want to be sending any of that stuff to Claude. So at the moment we have a bunch of our team just doing experiments, but we haven't sort of settled on, yeah, how we go forward with this task of using, like, our kind of thing is we want to use LLMs to enhance reconciliation, but we didn't think of actually using it directly in OpenRefine. I think always like in our head we thought, okay, we have to do something else because OpenRefine doesn't do that. But now with this extension, I'm thinking, maybe we can just think about actually doing something already with OpenRefine, because at least we don't have to reinvent the whole human in the loop like interface.
Yeah, I think definitely it's a very interesting use case. Thanks for sharing that. I think yes, we might be able to solve this problem because it's a multi-hop step to basically arrive at a potential candidate who fits the profile. So I think definitely using the LLM extension will get you to where you want to be. Uh, Interesting. But you also said you explored the Claude agent to do it. So interesting. So there you're kind of giving it a playbook to run with. Ability for it to kind of adapt to different contexts is going to be the interesting one. So, but this is a
Yeah,
very
yeah,
interesting use case. If you do have
yeah.
some more details, sample data which you can share for us to test with, we can
Yeah,
definitely work with you.
yeah. I mean, I can send here the Git for the Ecolog project. At the moment, we don't have, I think, anything proper running, but we have some repos with experiments, and we also have like one small experiment where colleagues used the, also we're trying to bypass the reconciliation service data and just use the Wikidata embedding space. So that was like one approach, right? Like we're trying different things just to see where we get the best performance. But also we are aware it doesn't make sense to use that for everything. Like it makes sense to use that for, so if you run 1,000 things and if you get like a rule-based non-LLM matching on like 50% or 60%, great, right? We don't need to waste LLM resources on at least 50% of the stuff. And then we only want to run the LLM on like the difficult things, right? Like the difficult parts that are not much simple rule-based stuff. Or like when we have the external context structure, like when we have a birth date structured or when we have an external identifier structure, that's easy. Then we can just use the existing reconciliation service. But what we're trying is the more, like at the moment, very mental stage of what can we even do when we have more tricky reconciliation. But I'll share the Git and then people can see what we've done so far. Like I said, it's not anything put together yet. It's more just different. We're trying different approaches and we're still very open to suggestions and like which direction to go.
That's definitely a good use case we can explore also in our grant application, Sunil.
Uh, yes, it's a good one. Yeah.
Any other question, comment, or shared experience in the room? One thing I've seen in part of presentation, and so I'm using also LLM a lot in different tasks, and in your second example, Partha, you were asking the LLM like to provide the answer, but also to provide like its confidence and like other information. And I really found this when I do batch processing, it's also part of my best practice. Often I add a line like provide your reasoning. So like explain me how you came up to that answers. And I find like so like when you get into the human in the loop part and you want to review or you want to improve your prompt, like you're not fishing in the dark, trying to understand like how it came up with that answer. Um, so using the confidence, but also adding like another line which is like, yeah, give me your reasoning, explain yourself on why you came up with that answer. And using the structured JSON is a very neat way to do in OpenRefine.
Yeah, as I said that for large number of records, sometimes when you give your textual prompt or JSON object prompt, it not always producing right kind of output for each and every record. But when we tested with the JSON schema, we found that almost the error rate is nil in case of large scale data set. That is one reason. Second reason is that uh, we are actually uh, sorry we are actually comparing the LLM output with all also using side by side ANIF machine learning framework developed by National Library of Finland. So we make a comparative between the LLM, ANIF. So or score or score, whatever you are saying. So in the same way, we also tried with large language model whether they that thing or not. And most of the surprisingly, when we compare statistically through a different kind of pair testing, uh, the matching in a locally trained SDG classifier is almost LLM is almost equivalent to that. Although LLM is not actually specifically trained with the different kind of relevant literature. It's a large textual base. But when we compare that, surprisingly the scores are almost equal. So that is one of the reason we tried that.
Any other question or comment for today? Thanks everyone for attending. I'm gonna end recording now and